In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3.3. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 10, we're asked to solve a differential equation. That takes the form of an equation with a dy dx in it. And how we solve these nearly always turns out the same. I don't want to say always because I'll be proven an idiot, but every time I can think of turns out the same. What you want to do is you want to separate this dy dx. So we get dy on one side and dx on the other side. With the dy, we get everything that has a y in it. And with the dx, we have everything that has a dx in it. So let's do that now. We have a sine 2y on the right. So if we divide that across, we leave this guy where he is, sine 4y, and be divided by sine 2y. The x's, they're already on the right. We have an x and a sine 3x. So this question, instead of the one up here, we can think of it as this, and how we do it is we just integrate both sides. So we add an integral in here. It now becomes two questions. Integrate this and integrate this. That's how I'm going to look at this. I'm going to just separate this. I'll work on this on its own, partially because I don't have a big enough board, and then I'll work on this on its own. It's okay for you to do this as well in the exam, and then later I'll put them back together with this equals. So first of all, let's start with this left hand side, this sine 4y over 2y. You can't do it as things stand. That happens all the times in integration. We have a good few different methods to try and solve things. You could try a substitution. You might want to try substitute the 2y or the 4y and see how that gets you. It's not going to get you anywhere. You could try it, and this will happen in the exam. It happens to everyone. You attempt something, you go a couple of lines down, and then you just give up. You realise you're wrong. You're doing maths, and you realise, this is the wrong path. Just put 1-2 lines through it and move on. Try the next idea. So next, you might try integration by parts. It doesn't look like two things multiplying, but it is. It's this multiplied by 1 over that. You could try that. It might take you another few steps to realise, oh, that's not looking good either. When you're dealing with trigonometry or trigonometric expressions, it's always worth thinking, can I change this into something? And that's what we're going to get here. We have a formula for sine 2y. You could try and change that. That's probably the wrong path to take down, because what gave me a hint in this question was the fact that 4y is 2 times 2y. That set off alarm bells in my head. It made me think of the sine 2a formula, where sine 2a is equal 2 times sine times cosine, but not for the bottom row, for the top row. Let me show you what I mean. Let's rewrite all of this, just the left hand side now. The top row, let's rewrite this. If I rewrite it as 2 times 2y divided by sine 2y, this is what I want to change. And let's change that into the top row, so it will become 2 times sine 2y cosine 2y. So that I've just used the double angle formula for sine. This is 2 times something. Becomes 2 times sine, that's something. Let's put a bracket in there, like that. But hopefully at this point you should be like, oh yeah, of course, because the bottom row also has a sine 2y. They just cancel quite nicely. So all of that work got us to, instead of this left hand side, got us to the integral of 2 can come outside of cosine 2y with respect to y. This is something we can integrate. It's not too difficult. We sort of need to substitute the 2y. So sometimes I do that slowly. I write y is equal u is equal 2y, and I substitute it in. But I think that most students like to do this just in their head. It's a simple enough way to do it. we're replacing this 2y with something, a u if you want to do it formally, but it's just cosine of something. The integral of that with respect to something is sine of that something. So the integral of this, the 2 is still out here, just becomes sine 2y. But we end up dividing by the derivative of this thing we've replaced. You can see that more clearly if you did the whole substitution. So we'll end up dividing by 2 here. Most students just remember cosine or sine or tan of any integer here. So 8y or 7x or anything like that. You just end up dividing by that number. And you don't have to remember it. You can use substitution or go through it in your head. Anyway, that cancels down, and this is the integral of this with just some constant. I'll call it C1 here. Right, that's the left hand side done. I am going to clear off the whole board and let's do the right hand side. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Right, let's leave the answer to the left hand side here and we'll concentrate on this right hand side. How do you integrate x multiplied by sine of 3x? We should go through the same steps we did before. Just keep trying things. There's really 3 main things to try. Substitution, playing around with the trigonometric expression, and integration by parts. That is going to be the answer here. Substitution, it's not really going to work out for you. If you substitute 3x maybe, you could also substitute x because they're practically the same. There's only a multiple of 3 between them, but we'll still be left with a u times sine a u. So that's not going to work out for us. We could try expanding sine 3x out. There's a couple of ways to do that. There's a double angle formula, or there's just 2 different angles added together. But really you're just going to make it more complex. There's nothing really nice to cancel with. This is a trigonometric expression and this isn't. So they're not really going to cancel too well. So we're really going to be left with integration by parts. So integration by parts tells us if we have 2 things integrating, in this case this thing and this thing, one of them has the dx with it. That's not so important for you to remember. But when we have 2 things integrating, that's the same as multiplying them together and then take away the other way around, v du. Now students tell me they have this list of rules how you can integration by parts. I don't bother with them. I just write down u, v, du and dv. Or instead of du, I don't write it myself, but I think it helps to think of it as the dx here. So I want u and I want the derivative of it. I want v and I want the derivative of it. The thing is, 2 of the answers are here. U and dv dx is here. You just have to decide which is which. There's no harm in just writing down whichever one, trying the question and seeing if it gets too difficult or you fail somewhere. But you can also do it in your head. For example, well, let me write the wrong one down. Let me write sine 3x here, sine 3x and x here. What's going to happen is we are going to differentiate this, which we can do. Yeah, I'll just put that down. Cosine 3x and 3. And we're going to integrate this, which we can do. And we're going to ask ourselves, instead of trying to do this question, these 2 together, is it easier to do these 2 together? That's how I think of integration by parts. And it's clearly not. X squared times cosine 3x, that's similar to this. It's actually even just harder. There's an x squared now instead of just an x. So the answer is, well, hopefully the answer is the other way. And I don't tend to write this. I tend to think this in my head. I think to myself, if I differentiate this and well, I think, can I differentiate and integrate first of all? So I can differentiate that, integrate. So that's no problem. So if I differentiate this, that'll make it simpler. It'll just be a 1. And if I integrate this, it doesn't make it much harder. It just becomes a cosine. Sine and cosine are very similar. So I already know this is this is what I should do. An x here and a sine 3x here. Because the derivative of x just becomes 1, and the integral of sine 3x, the integral of sine is minus cosine 3x, and we divide by this 3. So we end up getting that divided by 3. So the question is this multiplied by this easier to integrate? Let's write that down. Instead of doing all of this, is it easier to, let's not forget the u times v, is it easier to do, well, minus x cosine 3x over 3. We don't have to do anything to that, so that's definitely easier. Is it easier to do minus the integral of minus cosine 3x over 3? And yeah, this is quite simple to do. We can, first of all, two minuses make a plus, and we can bring the 3 outside to be 1 over 3. And we're just left with this integral. Quite simple. It's similar to what we've already done on the other side. This whole right hand side now becomes minus x cosine 3x over 3 plus 1 over 3. The integral of cosine is sine 3x, and then we divide by another 3. And that's it, plus some constant, we'll say constant 2, and we can also put these two 3's together to get 1 over 9. Next up, let me just clean all this off, and I'll write down, I already have one side of it here, I'll write down the two answers here, and we'll continue from that point. Okay, here's the two answers we previously got. Sorry, I'm missing a constant here. This is plus C2 I wrote. You can combine your constants. In fact, let's do that right now. My C2 here, take away my C1, just becomes a new constant. So C3, or again, you can just keep writing plus C here. I'll try and be consistent. This is pretty much it. They didn't ask for y in terms of x. They asked for a relation between x and y. This is already that. There's y on its own pretty much over here, x is over here. That's a pretty good one to do. You could of course just get the inverse sine of both sides. It just makes a bit more of a mess. Multiply by a half, you have y equals. With that said, we're not completely done. They don't want the constant. They gave us information to get rid of the constant. They told us that there is a point where y is equal pi over 12, and there's another point where, same point where x is equal pi over 2. Here's an equation with x, y and a c. I know what x and y is, so I can find c. That's what they want you to do. You're going to lose probably 2 marks if you've done everything else and don't finish with this. Let's put it all in. This will become sine 2 times pi over 12 is pi over 6. That's sine of 30 degrees, which is just a half, is equal minus 1 over 3. What's that? Pi over 2 cosine 3 pi over 2. We'll draw a picture to figure this out, or just use your calculator. Plus 1 over 9 sine 3 pi over 2 plus some constant, C3. Let me just draw cosine here and sine. Cosine looks like this. This is 2 pi. That's pi here. So which one we got? We have cosine 1.5 pi's. That would be right here. That's just 0. That whole thing goes to 0. We have, let's draw sine. Sine looks like this. You can let your calculator do this, of course. That's pi, that's 2 pi. We're interested in 1.5 pi again. That's here. That's minus 1. This just becomes minus 1. And as I said, use your calculator for this, or I just happen to remember it's a half. That becomes a half. So write that out again. We get a half is equal to minus 1 over 9 plus C3. Rearrange that, we get C3 is equal to a half plus 1 over 9. Let your calculator do it, or put it together yourself. This would be 9 over 18 plus 2 over 18, which is equal 11 over 18. I think you would get full marks for this, but maybe not. Let me just squeeze in a box here. What the examiner what they really want to see is your final answer is this line here again. Sine 2y is equal minus 1 over 3 x cosine 3x plus 1 over 9 sine 3x, and instead of just constant, they wanted to write 11 over 18. This is definitely full marks. I think you probably got it down here. Okay, that's not it. Sorry, I thought that was it for question 10. That was 8 marks. That was a good long question, but they added in one more bit. Let me clear off the board and try and answer that. For part B, they pretty much tell you find y. They tell you what x is, but they ask you what y is. It's only 2 marks for this, so it doesn't take us much work. I left this final answer we had from part A. So let's write it again with what they told us. X is equal to 0. We'll worry about what y is later. They tell us y is between 0 and pi over 2. So if I write all this again, I get sine of 2y is equal. X is 0. So 0 multiplied by anything, that's gone, it's 0. X is 0 again. 3 times 0 is 0. Sine of 0 is 0. That's gone. We're just left with 11 over 18. That's why it's only 2 marks. Find out what y is. We saw this 2y is equal the inverse sine of 11 over 18. But let me stop you there. This will give you an answer, of course. But remember, your calculator is stupid. It'll only give you one answer, and it might not even be the right answer. I want you, whenever you do this inverse sine or inverse cosine, to think about the question. They told you the answer has to be between 0 and pi over 2. This is 2y though. So one way to do it would be to realise that 2y has to be bigger than 0 or pi. That's one way. And I like to draw this. I like to draw sine of something. Sine of something looks like this. And this is 2 pi up here, although this is for 2y anyway. And they're doing 11 over 18, somewhere here. You're going to get this answer, and many other answers. But we need to realise that it's just these two we need, because 2y is between 0 and pi. You could also just get out every answer that the calculator or the sign would give you. Write out 10 of them. Or I sometimes recommend writing about 4 of them out. These two, next ones. And then just dividing them all by 2, seeing which of your answer fits in and throwing the others away. Or you could think of it out first and say 2y is between 0 and pi, therefore these are the only 2 that work. Either way, you should get for your answer, your calculator will first of all give you 0.65746, but then you need to use your brain. That'll be this one. You need to use your brain to figure out this one here. If this is 0.6 away from 0, this is 0.6 away from pi. So pi minus this is your other answer. That'd be 2.4841, something like that. But your final answer is what's y? Y is equal half of both of these, which is 0.329 is one answer, and half of this is 1.24. Remember, they didn't ask for how many decimal places, so it's always 3 significant figures. 3 significant figures, 3 significant figures. I often say to students, it doesn't matter if you have too many. So I nearly advise students just always give 5 significant figures. It's make sure you won't lose a mark. Okay, that's it for question 10. If you have any follow-up questions from that, let me know in the comments. I'll do my best to answer. Thanks for watching and have a great day.